Okay, so we are finally getting around to the applied videos. And we're starting off with Stats Year 1, which is Applied Year 1, Chapters 1, 2, and 3. This is data collecting, processing, and representing. I've combined 3 chapters into one because there's a lot of overlap with them and they often get asked about with each other in exams as well. So this first slide is pretty much everything to do with Chapter 1, which is all to do with data collection. It's a lot of different terminology, often little 1 or 2 marker questions in the exam. So you've got to know these definitions, and I'm going to talk through them because I can add some more detail and a bit more understanding to some of these parts that we've got here. So we'll begin by looking at the term population, which means the entire set of items. The items are sometimes referred to as the sampling units in the group being studied. So we often think of population as about people living in a country, but if you were studying, say, the members of students in your class, then the population is the members of students in your class. So the census is where you measure every single member of a population. Well, if your population was just your class, you could just ask 30 people. But if you were wanting to do something for, say, I don't know, like a whole office building or something like a much, much bigger scale, this can be pretty expensive to do and it can take a long time to do. It can be very accurate because you're then sort of getting information from absolutely everybody. But there are some other disadvantages. This is what we mean. A green part is what I've put as an advantage and a red part is a disadvantage. Another classic disadvantage for why we don't always want to do a census is that sometimes the testing itself destroys the items. So I think it was actually in a past paper question. It was thinking about why would a factory not want to do a census of the lifespan of their batteries in a factory? Well, that's because to test a battery's lifespan, you would actually have to deplete all of its energy. And if it's got no energy left, you can't sell the battery afterwards. So by testing the life of the battery, we've actually destroyed it. Now, a sampling frame is a list of sampling units. It might be something like a list of students in a school, a list of houses on a street, but certain things will not have a sampling frame. For example, if you were trying to research about the weight of fish in a lake, we're not going to have a list of fish that live in a lake. It's just not possible. So that's going to restrict some of the particular types of sampling that we can do here. So we've got these 2 general sort of groups of sampling. We've got the random and non-random sampling. Now, within random sampling, there is simple random sampling. This is where, in the definition of it, that there is an equal chance of being selected. Each single sampling unit has an equal chance of being selected. And to do this, you can either assign each thing in the sampling frame a random number and then use a random number generator with that sampling frame. Sometimes they say you can do it where you can write all of the individual sampling units on pieces of paper and randomly select them from a hat. That's kind of another way that things are often described for a simple random sample. The good thing is it's bias free because everything has an equal chance of being selected. The bad thing is that you need to have a sampling frame. You can't do random sampling for those fish in a lake because we don't have a list of all the fish that live there. Now, systematic sampling is slightly different to simple random sampling. It can often be a bit quicker to use as the advantage here. You take every kth pick, you pick a random number between 1 and k for a starting point. So, for example, if you were going to take k as 10, you'd take every 10th unit, you'd pick a random number between 1 and 10. Let's say you got 3, and then you would take that as your start point. So you would have 3, then 13th, then the 23rd, then the 33rd, etc., etc. Very quick to use, but you do still need to have a sampling frame because you need to have all of the units listed to be able to do this. Stratified sampling is where it proportionally represents the strata or groups in the sample to reflect the population. So this might be where you think that the thing that you're studying is going to have some particular characteristics or groups that affect the outcome. For example, if you were going to be looking at the average height of people working in an office, you might think that the number of men and women should be taken into account the proportion in the actual office itself, because we know that on average men are taller than women. So we would want that kind of proportion of men to women in the office to be reflected in the sample as well. And the way we do this is once you've sort of decided how many people need to be in each group, you then fill those groups with either simple random sampling or systematic sampling. It's really good because it reflects the population, so you have the same sort of structure of the population. But the bad thing is you do need to have clear strata for the population. Obviously, you do need to have a sampling frame to do this. Now, non-random sampling, we have two kinds here. We have opportunity sampling, which is the sort of more basic version. This is just where the sample that you're looking for is based on who or what is available. It's literally just the first things that you come across. So it's easy and cheap to do, and it's unlikely to be representative because you might be, so for example, the classic example for opportunity sampling is you're just sort of on the street doing a survey with people who walk by you. It's unlikely to be representative of the population because if you're stood in a particular location, you're only getting people who live in a particular area, but it's very easy and cheap to do. Now, quota sampling is like a variation on opportunity sampling. It's a bit like stratified sampling. So what you do is you start with different quotas to be filled to make up your sample, but they're not necessarily representative of the population. And then those groups, those quotas that you have, get filled using opportunity sampling as just the first ones that you come across. So if I just link back to what we'd said about the fish in the lake here, we might say to ourselves, okay, well, I know in general that the sex split between male and female fish in this lake is off. I'm imagining it's going to be something like, I don't know, 60%, 40%. I will make sure that in my sample, I will have 60 males and 50 and 40 females, excuse me. And then to fill those groups, you will literally catch a fish and see if it's male or female, and then you'd assign it to one of those quotas. And then when a quota is already full, you just keep putting that fish back. And in terms of common sense stuff, you might need to say things in your description here, like, oh, once a fish has been removed from the lake, you put some kind of marking on it so that you know not to count it again. No sampling frame is needed for this, which is why I was talking about it in the context of those fish in the lake. But it is not random because it's still using opportunity sampling. So there is the case of some potential bias. And thinking of those fish in the lake there, the fish that you catch, maybe the fish that you catch are all smaller, so they're easier to catch, in which case you might end up with an incorrect reading for what you think the average weight of fish might be. So you've got to use a little bit of common sense with that. And common sense is not necessarily something that we all have in heaps and loads of. So we hope for the best and are just trying to think what is the best way of making sense of these. So different data types that we've got here. There is qualitative data. This is non-numerical data, things that it's just like words, colours, stuff like that. Quantitative data is basically what we're going to be using in A-level maths here. It's just numerical data. And then we have discrete and continuous. You probably do remember this from GCSE. Discrete is data that can only take certain values, often integers, and continuous data is data that can take any value within a range, and it obviously must be grouped together because you might not get two that are exactly the same, so we often put those in groups. The example I often use for discrete and continuous is to do with shoes and feet. Shoe size is discrete because it can only take set values. You go into a shop, you can either have size 10, 10.5, 11. Continuous, on the other hand, might be the length of your foot. When you measure the length of your foot using a ruler, you'd probably do it to the nearest centimetre, but you could do it to the nearest millimetre, or you could do it to centimetres to 5 decimal places. You can get lots and lots of different readings where you'd have to kind of measure them. So that's the difference between discrete and continuous there. So I'm going to do a couple of short questions here. I'm not going to give as much detail as I might do in an exam for the sake of brevity, but we will just get a bit of a flavour of the kinds of things that we might be asked here. So it says, Jack stands outside the supermarket to collect a sample size 30. What type of sampling is this? Well, clearly there's no sampling frame that we have here, so it's definitely going to be one of these non-random samplings down here. And he's not trying to fill up, say, 15 male and 15 female, which would be quota sampling. He's literally just doing who or what is available to him at the time. So this is an example of opportunity sampling. Okay, and then our next question that we have here says that Junaid has a detailed list of the students in his school. He wants to find the average height of a student in his school. Which sampling technique would you advise? So I think, because we've got a detailed list of the students in his school, we've definitely got a sampling frame. I think we're likely to be using one of these three that we have here. Because of the fact that we are trying to find the average height of students in his school, and we know that students in year 7 are going to have a very different height on average to those in year 11 or year 13, I think we're going to want to use stratified sampling here so that the proportional makeup of the year groups in the school is going to be reflected in the sample as well. So what type of sampling technique would we advise? We would advise stratified sampling. And I'm going to give a bit more detail. I'm going to say that we should stratify by year group. And what I mean by this is, let's say that there was an equal number of students in each year group, there should be an equal number of students in the sample from each year group. Or perhaps the sixth form is really, really big. So maybe the sixth form, year 12 and year 13, the year groups are double the size of year 7s to year 11. You'd want to make sure that that is truly represented in the group. And you just use that using kind of classic sort of like proportional techniques or percentages. The percentage of those students in the whole sample should be the same as those in the whole population. Now, chapter 1 does also cover the large data set. Now, large data set for Edexcel is to do with weather. I'm not including it in this just in case it's different exam boards of people that are looking at it. Plus, the large data set has a lot of information. I have a dedicated video for it that you can search for on YouTube. If you want to hear a bit more about some of these things, you can also go to the Everything to Memorize Statistics video on YouTube as well. And then the last thing I'll say on this before we start looking at the data processing is you must be prepared for skills from these first 3 chapters to be blended with the large data set and also with later chapters. They love to blend this with lots of different things. And also understanding the ideas and not just the skills is very important because, like I said before, they do kind of pull out some of like the common sense about how you might approach some of these data collection things. Okay, so for the next part we'll be looking at is some things to do with data processing. So once you have the data is often going to be tabulated. The opposite of it being tabulated would just be in a list. If the data was in a list, we would be using GCSE techniques. Honestly, I've not seen a question where the data is in a list, and if it is, you can just use your GCSE skills for this. I'm just going to focus on what happens when data is tabulated. Now, once the data is in a table, whether it's discrete, continuous, or grouped, you are always going to use these things to find the median, the quartiles and percentiles and things like that. This section is all about different measures of location, meaning that if you had all of the data and you were trying to pick one value to kind of represent that data, it's the location that that data would have on a number line. So literally just kind of like a physical location of, oh, the average height is 1.6 meters. It's located there. So to find the median, you do the number of terms and divide it by 2 to find that position. Lower quartile and upper quartile, sometimes called Q1 and Q3. You obviously go a quarter of the way along for the lower quartile and 3/4 of the way along for the upper quartile. And if you're asked to find a percentile, in this case an example of the 40th percentile, you do 40 over 100 times by the number of terms that you've got to find out the position. Once you find that position, you have to use cumulative frequency to figure out what that particular value is that is being represented by these positions. And if the data is grouped, you're going to have to use linear interpolation to find that estimate for either the median, the lower quartile, etc., etc. Now, the mean is obviously another measure of location that we've got here. This is probably the definition we're most familiar with from GCSE, that the mean itself, you sum up all of the x values and divide it by how many there are. But more commonly, we'll be using this one where for sort of data in tables, we have to do the x value multiplied by the frequency and add them together and divide it by the sum of the frequency. So the sum of the frequency is obviously how many things there are, and you do the frequency times by x. So in this case, we'd take the midpoint, x would be 75, you multiply it by 35, 65 times by 45, you add all of those things together to get this top part, the sum of f of x. Now, of course, with location, we also could say that mode is something that we could do. I'm not adding mode in here. This is A level, you know these things. You've looked at mode probably since year 7. So spread is different to a measure of location. Once we know the value for something like the variance or the standard deviation, or even the interquartile range or the range, those things don't tell us where the data is located on a number line, just how kind of spread out the data is. So variance is sigma squared. If you want to find the standard deviation, which is just sigma, you obviously just take the square root of this thing that we have here. So this is for the variance, you take the sum of x squared divided by n minus x bar squared, or this more complicated looking thing over here. But I want to give you this way to help you to try and remember how you find these, or how you remember this formula. MSMSM. It is the mean of the squares minus the square of the mean. Well, this minus the square of the mean part is easy. There's the minus the square of the mean. So you find out the mean, you square it, and you're going to subtract it from it. The first thing is the mean of the squares. This means you take the x values and you square them first. then you add them together and divide it by n. So you're finding the mean of the squares. Same thing in this one. It's like a variation of this formula. Instead of doing the frequency multiplied by the x point, you're doing the frequency multiplied by the x point all squared, and you're dividing that by the sum of the frequency, which is, again, the same thing as how many terms there are in total. So that's a little way to help you remember this, okay? Now, there is a very, very niche variance formula, which is that the variance is Sxx over n. I have seen them ask this once in an AS paper for Edexcel. Very, very, very sneaky of them, but it is in the formula book. It comes up in the formula book under standard deviation, where they say this is this, okay? Now, I'm not going to go into the detail of what Sxx is. If you are doing further maths and you're doing further statistics too, you will know what these things are, but I'm not going to go into it because obviously it is a further maths kind of thing that we have. So for coding, if we had stuff to do with x and we changed the x values by multiplying by a and adding b to come up with some new variable y, well, if we wanted to find the average for y, we take the average or the mean for x, we times it by a, and we add on b. Simple. If we wanted to find the standard deviation for y, we find the standard deviation for x and we just multiply it by a. Adding on b does not change anything to the range, the interquartile range, or to the standard deviation, okay? Adding things does not change any of the measures of spread, doesn't change variances either, because if they're all shifting up by the same amount, they are still as spread out as before. But if this was variance, we would not be multiplying by a, we would be multiplying by a squared, because obviously variance is the standard deviation squared, so it makes sense that we have that a is squared as well. Okay, let's put some of that stuff into practice with an example that we have here. It says the table below gives information about the ages of 160 passengers occupying 3 coaches on a trip to France. And this table is kind of sort of like a horizontal table. You could see it presented vertically as well. Exactly the same thing, just kind of looks a little bit different. So we've got the different ages. You can see there are perhaps more mature people on this coach trip, which is perhaps typical for a coach trip, but it looks like they've brought some children with them, and maybe there's some teenagers there as well. So the first thing it says is that given that Q1, remember Q1 is the lower quartile, is 32, find an estimate for the interquartile range, giving your answer to 1 decimal place. Now you'll notice I didn't talk about the interquartile range as a measure of spread on the right hand side, but that's because it's in GCSE, and I think you probably know that already. So the interquartile range is the upper quartile, which is Q3, minus the lower quartile, which is Q1. So what I'm going to do is I'm going to try and find out what the upper quartile is. So I'm going to look for the position for Q3. Now the upper quartile, we've talked about over here, you do the 3n over 4, 3/4 of n. Now in this case, we know that n is 160 because that's how many there are. It's also the sum of the frequency. So the position for Q3 is going to be 3 multiplied by 160 divided by 4. That's 3/4 of 160, which is obviously going to be the 120th term. Now to find the 120th term, we're going to use some cumulative frequency with these frequencies that we have here. So the cumulative frequency between 0 and 10 takes me up to 16. If I was going from 0 to 20, that would be the first 25 terms. 0 to 40, I add on another 25. 0 to 60 would take me up to 80 when I add on the 30. This will go up to 125, and 125 plus 35 gives us that 160, which is our n that we've got there. So we are looking for, where is the 120th term? Well, this takes me up to 16, this takes me up to 25, this takes me to 50, this takes me to 80, this takes me to 125. So I know that this group here is where the 120th term is. This group is actually taking me from 80 to 125, and it's between 60 and 70 that we've got here. So we are saying it is between 60 and 70. This is my little visual tool to help us. And we've just said that that group is going from the 80th, I always write 80th and 125th to remind me that the top part is to do with the years and the bottom part is to do with the positions. We're looking for the 120th term. Now, obviously, 80 and 120, if I was saying 100th, it's going to be somewhere in the middle. 120th is going to be somewhere over here. And that helps me just visualize what kind of answer that I'm expecting. I'm trying to say, what is this answer that we have here? Now, to find that answer, I'm going to say for the years, I'm saying it's 60 years plus some extra amount, some fraction of this gap that we've got here. This gap between 60 and 70 is 10. So to find out what the value is that's inside this little block that we've got here, I'm going to say I'm adding on some amount onto 60, and it's some fraction of this 10 that we have. Now that fraction is reflected in the gap along the bottom. The fraction is between 80 and 125. Well, that is 45, and between 80 and 120. So I want to go 40 out of 45 along that section. If I go that fraction along the top, I will end up at this value. So on my calculator, I would do 60 plus 40 over 45 times 10, and I get my estimate now for the upper quartile is 68.888. I think it's said to one decimal place, so I'm going to go for 68.9 years. That is going to be the upper quartile, which now means that the interquartile range is 68.9 minus the lower quartile, which they said is 32. So I get 36.9 years. So that is the interquartile range that we've got there. And it says then for B, a measure for an outlier is found using Q1 minus 1.5 times the interquartile range. Is it possible for the youngest passenger to be considered an outlier? Well, we don't know anything about the youngest passenger. We just know that they are somewhere between the age of a baby and 10 years old. Well, let's figure out Q1 minus 1.5 times the interquartile range. So I'm going to do Q1 minus 1.5 times by the interquartile range. So that is 32 minus 1.5 times by 36.9. 32 minus 1.5 times 36.9, and we get minus 23.35. So an outlier is something that is outside of that range, something that is even lower than this. Well, nothing's going to be able to be lower than that, right? So an outlier is not going to be an outlier for this. It says, is it possible for the youngest passenger to be considered an outlier? I just need to explain, no, not possible. Not possible. The youngest passenger cannot be younger than a negative age. Or you could say something like, if the youngest person with 0, 0 is greater than this, so clearly cannot be an outlier. Now, outliers, in this case, they gave us the measure of an outlier. You'll always be told in the question what the outlier measure is going to be, okay? So for part C of the question, it says, find an estimate for the 30th percentile age of the passengers. So 30th percentile, you can either do 0.3 times by 160. I'm actually going to do it with the method that I'd said on the other side. So this is for the 30th percentile position. We do a P with a little 30, a bit like here when we did the quartile, we used the letter Q. So I'm going to do 30% of 160. I think I can do that in my head because 10% is 16. And so 16 times 3 is 48. So it is the 48th position. Right, we're now going to try and figure out, this was for Q3, by the way, it was in yellow. We're now going to try and figure out for P30, where is the 48th? Well, this group here, I think, takes me from the 25th to the 50th. So I think this group here is where the 48th is going to be. I'm going to do another example of interpolation because it's something people don't tend to like very much. So we're going between 20 and 40. That's taking us from the 25th term to the 50th term. And I'm looking for the 48th, which is actually going to be all the way down here. So there's the term that I'm looking for. Well, I am starting at 20, and I'm going to add on some fraction of this gap. This gap between 20 and 40 is 20, and that fraction is going to be, so I've got from 25 to 50, that's 25, and from 25 to 48, well, that would be 23. So the fraction is 23 25ths of the way along that top part. So I'll quickly do that on my calculator. And I have 38.4. 38.4 years. So the 30th percentile is 38.4 years. Now, giving you a bit of context of what that means that 30% of people are 38.4 years or lower, and 70% of people are 38.4 years or older. And obviously this is an estimate, and we've used linear interpolation, which means we are presuming that the ages of these people are equally distributed in these groups. In reality, they may not be equally distributed, in which case this idea, this theory of linear interpolation is not going to be it's not going to hold up very well. We then want to calculate an estimate for the mean and the standard deviation of the age of the passengers, giving your answers to one decimal place. And they've saved us some time. They've already told us the sum of f of x is this and the sum of f of x squared is this. Now, the sum of f of x, just to kind of tell you where this comes from, this is where we take the midpoints of these group, we multiply them by the frequency and we add them up. So like 5 times 16, 15 times 9, 30 times 25, etc. When you do that, you get 8,015. This one is found where you take the midpoint, you square them first, then you multiply it by the frequency. So it's like 5 squared times 16, 15 squared times 9, 30 squared times 25, and that gives you obviously a much bigger value. So I'm going to use those information they've given us, the sum of f of x. I think I might have said the sum of f of x. I didn't mean that, just the sum of fx. So the mean that we have, that is the sum of fx divided by the sum of f. The sum of fx is 8,015, and we know the sum of the frequency is 160. So 8,015 divided by 160, and that is, to one decimal place, 50.1 years. So the average age is 50.1 years. Now we're going to do the standard deviation. So I'm going to make sure that I'm doing the square root sign. It is the mean of the squares. So that's going to be divided by 160 minus the square of the mean. Okay? So when I actually put those values in, and I'm going to put this as a big fraction here, it's going to be the sum of fx squared, 486,925. So that's 486,925 divided by 160. And I could write 50.1 squared, but I already rounded that. So what I'm going to do is I'm actually just going to write it as the previous part, which was 8,015 divided by 160 all squared. I'll get that on my calculator nice and quick. Make sure I don't type any numbers wrong. Often that's where the mistakes get made here. People, when they're typing in long numbers, and also while they're trying to make YouTube videos at the same time, they often make mistakes when they're typing them in. But we get that the variance, the standard deviation that we have here is 23.1 years that we have. And then part A of the question says, it is later discovered that the age of a 42-year-old man was incorrectly recorded as 52. Explain how this affects the calculations from part D. So we have a 52-year-old in this group who was not supposed to be 52, they were supposed to be 42. But actually, it's not going to change anything because they still would be in the same group. So I'm just going to say for this part E, how would it affect the calculations? There would be no change. The man is still in the correct group. Okay, last part is data presentation. And I'm looking at particularly just histograms here because we need to make sure for this chapter that you are familiar with box plots and cumulative frequency curves. I'm not going to cover them in this video. They are GCSE topics. Nothing new is added to them. If you are not very familiar with box plots and cumulative frequency curves from GCSE and you just want a bit of a refresher, if you search Bison-Math GCSE box plots every question, Bison-Math GCSE cumulative frequency graphs every question, you'll be taken to my other YouTube channel where I go through lots of GCSE questions on these particular topics, and you will have your minds refreshed very, very quickly. And some of those questions are pretty tricky and challenging, but I just thought I would mention that because I'm not going to cover it in this video. Now, the reason I'm covering histograms is because at GCSE, it was just that the area of the histogram was exactly equal to the frequency. But for some reason at A-level, the area is just proportional to the frequency, which means that you just say that either the area is equal to some kind of scaling factor times the frequency, or alternatively, we could say that the frequency is equal to some kind of scaling factor multiplied by the area. And it really would just depend on either of these ones which you want to use. They're both equivalent, but it just depends. If you're doing lots of things where you want to find the frequency, it's often easier to do it like this. Or if you're just finding areas, I mean, it really doesn't matter. I just wanted to show you they could work either way. Now, I will talk to you about this part as well, but I just wanted to say, if you had a curve being used to model a frequency density or a corresponding frequency polygon, so instead of it being like this shape, let's say that they said the frequency polygon was being measured by some kind of curve like this for these different blocks that we might have. If we wanted to find the area underneath this curve, then it must be equal to the frequency. And what I mean by this is if you imagine all of these blocks, well, we're trying to say that it's equivalent to the area underneath that curve that we have there. We know that the area is proportional to or equal to the frequency. So if we were going to integrate underneath that curve, we should be finding the frequency. And for some reason, when they've asked this, it's always been equal to the frequency, not proportional to the frequency. And this is something that's not in the textbook, but it has been asked about if you're doing Edexcel in AS 2022 and A2 2023. And it basically becomes an integration question. You're integrating underneath it, and the area must be equal to the frequency that is being analysed in that question. So you can have a look at those questions to see if you can do those. This AS one is easy integration. The A2 one is some really quite tricky integration that we've got there. So we're going to just dive straight in with this last part. So we're going to have a look at this one that says a partial histogram has been drawn to represent the heights of buildings in a particular district of a city. Given that there are 24 buildings with a height of 5 meters or shorter, and that the 42 buildings with 10 meters or taller complete the histogram. And as an extension, I'm going to remind you that you need to know how to use your calculator to find the mean and standard deviation from a table, just getting it typed into your calculator. So as you'll see, GCSE, there would normally be some values here. There is no longer any requirement for that because of the fact that the area is just proportional to the frequency that we've got there. So I have given us this extra table. They may or may not give you that. I'm actually going to add in a little extra part for us to figure out some of these areas that we've got. Now, when you calculate these areas, as there's no units here, you can kind of decide to do them in whichever way you like. My brain kind of sees that this is like a big block and a big block and then a mini block. So it looks like it's a 1, a 2, and then this is 0.4 of a block. So that's like a 2.4 for this part. This one's nice and easy. You can just see that there's 4 big blocks. This one we can see there's what, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, and then 2 0.6s. So that would be 10 plus 0.6 plus 0.6, 11.2. We don't have the 10 to 12.5, but we do know that the area of this part, that's 1, 2, 3, 4, 5, and then we've got 5 lots of 0.6, which is 3. So that means that the area is 5 plus 3, the area is 8 that we have there. Okay, now we know something. We know that there are 24 buildings with a height of 5 meters or shorter. So that means these two sections here represent 24. So I'm just going to write that down, that the area, I'm actually probably going to use this frequency equals K times by the area. So we know that there are 24 buildings that are being represented by an area of 2.4 plus 4. So the area of those two is 6.4. And this is for my 0 to 5. So let's find out what K is. I'll do 24 divided by 6.4. That is 3.75. So K is 3.75. We've now got this formula, and our formula is now telling us that the frequency is equal to 3.75 times by the area. Okay, well that's useful because I can actually start filling these things in that I'll need later. So I can do that for all of these. I will do 2.4 times by 3.75. That's a frequency of 9. I'll do 3.75 times by 4. That's a frequency of 15. And I'll do the 11.2 times by 3.75. That is 42. And for the last part, I can do the 8 times by 3.75, which is 30. So I can't finish the histogram yet because I don't know actually what this frequency is, but it does tell me something, right? It says 42 buildings with 10 meters or taller. So that means these two things must be 42, which means this must be 12. So I now just need to figure out what the area is going to be. So I'm now going to say the area for the 10 to 12.5 bar. So we know that the frequency is equal to 3.75 times by the area. The frequency is 12. And so the area will be 12 divided by 3.75, which needs to be 3.2. So I need 3.2 blocks, okay? So we've got, that's 1 block, 2 blocks, 3 blocks. Okay, 3.2 would be to there and finishes off like this. So I've got it drawn up to that 3.2 for that section. So I've completed the histogram. Now, the last thing, the extension, is by using your calculator, you need to write down the mean and standard deviation of the heights of the buildings. Here I did it using calculations and typing things in. If it was just like a 1 mark question to find the mean, you can actually just type this into your calculator. And I'm not going to show you this, but I am just going to have it on my calculator. You would need to use the midpoints, okay? So the midpoint of these two is 1.25, 3.75, 7.5, 11.25, and then this one, when you add them and divide it, I think I've had it before. Sorry, I said 11.25 and 18.75. You would type in your calculator, these are your kind of X values. You would then type the frequencies of your 9, 15, 42, 12, and 30. And you should know how to do this on your calculator. If you're not sure, go and just YouTube. The calculator guide is fantastic for this, how to find the average from a table. I will then get the pieces of data from this for my extension. And we end up with, from my calculator directly, that X bar is exactly equal to 10. And then sigma X is how it's written on the calculator, but the standard deviation is 5.9723 significant figures. So I know I haven't shown you very much there, but make sure on your calculator you are aware of how to find averages and stuff by just getting them typed into the calculator. It can be a big time saver and also can help you check that you've done everything correctly. So that is everything for chapters 1, 2, and 3. Of course, you must do exam questions for this, but the rest of the applied videos will all be coming soon, and I hope to see you in another video soon, guys. Thank you.